My name is Oveis and this video is about ABG imbalances and interpretation of acid-base imbalances by ABG. First of all, I need you to know and consider CO2 as acid and HCO3 minus as a base. Okay, we know that. CO2 is acid, HCO3 minus is a base. It is easy to prove, but I guess we don't need to, at least for here. So no, CO2 is an acid and HCO3 minus is a base in our body. And also, we need to know that normal pH is about 7.4 and CO2 normally is about 40 and HCO3 minus is about 24. This is the normal range. This is the normal. Okay? And also, I need you to know that in ABG problems, when we have some changes in one of these two, it will change another one. Consider these two as two characters in our body. Two characters that our body needs to make them equal. Okay? CO2 and HCO3 minus. The body tries to make it equal in our body. So when we are losing, when we are losing, for example, this one, body tries to lose this one to make everything again equal. Okay, try to make it equal, and we call it compensation. Okay, and for example, when this one is increased, body tries to increase this one. You know, I'm trying to say that compensation is only about going in the same direction. For example, if CO2 is increasing in the body, for example, as we said, CO2 is acid in our body, and this one is base. And the body tries to make these two the same, equal. Okay? So when we lose acid, body tries to lose base, and when, for example, increase in acid, body tries to increase in the base to make it again equal. Okay, I guess I'm clear here. I hope so. Another thing that we need to know, that no compensation is equal. For example, when we have a problem, for example, in acidosis or something, acidosis or alkalosis, the body tries to make it to alleviate the problem, but it never can be perfect, and no compensation is perfect. Okay, and we also need to know that. Okay, and here, I want to make a memory tool for you. I want to make a memory tool for you to easily calculate the compensated number. Okay, and according to the compensated number, you can say that if it is, for example, acidosis with metabolic acidosis with compensation of respiratory system, or metabolic alkalosis, for example, alkalosis with mixed with respiratory acidosis or respiratory alkalosis or whatever. Here I can make some. I can make two memory tools for us to make it very easy and lasting forever. Okay. Did you ever heard about something like 24/7? When we say 24/7, it means every day and every time it will be available something like this. So we set something like 24/7, and now we're doctors, right? We're different, or at least we think that we are different. So we can change it to 14/24/7. So know this forever, 14/24/7. And another tool for here is 1.5 bicarbonate plus 8. So what are these? What are these for? I want to say that this part is for respiratory system, respiratory problems in the system. So when we have some changes in CO2, we use this part to calculate the bicarbonate. Okay, but this one is for metabolic alkalosis, and this one is for metabolic acidosis. So, with some examples, it will be easy for you. For this one, this is for acute respiratory acidosis. This one is for chronic respiratory acidosis, and this one is for acute respiratory alkalosis, and this one for chronic respiratory alkalosis. And if you have some problem to know that, to remember that this one for acidosis, which one was for acidosis or which one for alkalosis, we go from acid to base. Okay, and you can learn it by, for example, acid is A is sooner than B, or acid C is sooner than alkalosis, than L. What I want to say here, just know this one and this one, and you will be fine. Okay, 14/24/7 and 1.5 bicarbonate plus 8. If you cannot remember the 8, also, you can say that 1.5 bicarbonate plus, maybe you forget the 8. You can say that bicarbonate is the same as 8, just bidirectional B. Okay, so I'm done with the lesson of metabolic acidosis and alkalosis in the ABG. With some examples, we will be clear about all of these. Okay, so the first example, we have pH equal to 7.6 and CO2 equal to 80 and HCO3 minus equal to 44. So we can solve this together. pH is basic, 7.6 is basic, so this is alkalosis, for example. This is base, okay? This is base. We said that CO2 is acid in the body, so we have, the normal range for CO2 was 40, but now it's 80, so it is increased in acid, so it is acid. Okay, so here we have acidic problem, and here we have increase in the base. We said that this is base, Normal was 24, so it is increasing the base in the base. So we have base here, and we have the pH, which is basic here. So the culprit, we just found the culprit. The culprit is this one, because this is basic, and this pH is the base, is basic. Okay, it is alkalotic. So the problem is with bicarbonate. So we start with the problem. All right. So 44 for bicarbonate. It means that here we have metabolic. So we have metabolic alkalosis. So now we know that the problem is bicarbonate. Now we want to know what is the compensated number for CO2. Okay, we need to know what is the compensated number for CO2. And after that we can interpret all this stuff. Okay, so we have metabolic alkalosis. Where is metabolic alkalosis? It is a 7. You know, this is separated here, and this one, 7, is metabolic alkalosis. What was that? This is according to 10-point changes. This part is according to 10-point changes. 10-point changes with each other. So we have 44. So we have 20, because the normal was 24. 44 minus 24 is equal to 20. So we have 20 point increase in bicarbonate. So 20-point increase in bicarbonate. As we said, every compensation is in the same direction. So when we have 20-degree increase in bicarbonate, first of all, we have increase in CO2 if we want to compensate anything. Okay, so when we have 20 degrees increase in HCO3 minus, we have here we have 7-point increase for 10-point increase in bicarbonate. Now we have 20-point increase in bicarbonate, so we have 7 multiplied by 2 is 14, so we have 14-point increase in CO2. So the normal CO2, the compensated CO2 has to be 14 increase in CO2. So normal CO2 is 40 plus 14 for compensation. So the number that we expect is 54. 54 is the number that we expect for compensation. We expect CO2 to be this number. Now, when we look at here, we see that CO2 here is 80. So it is more than 54. If it is more than 54, it means that we have more CO2, more than we expect. We expect that it has to be 54 for the compensation, but now it is 80. So it is more than what we expect. So it is more than what it should be. Okay, so we have more CO2 in the body, so we have some sort of respiratory acidosis because it is more than 54. So we have respiratory acidosis. If the number of CO2 was, for example, 20 or 30 or 40, it was lesser than 54, so it was a component of respiratory alkalosis. If it was 54 or something around this, it was only metabolic alkalosis with respiratory compensation.